All right, the last thing we're going to look at in this lesson is graphing quadratic functions. And remember, a quadratic function can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a not equal to 0. So the parent function is f of x equals x squared. So if we want to graph one of these quadratic functions, the first thing we always want to do is determine the vertex. And the vertex is the highest or lowest point on the graph, and it's where the direction of the graph changes. So once we find that vertex, what we want to do is put that in the middle of the t-chart and let that dictate how to choose more x values. So the vertex is always where the x term equals 0. So in this particular problem, my x term is x squared. So the only number that I can square and get 0 is 0. So I'm going to put 0 in the middle. And then generally what we do is choose two numbers to the left of the vertex and two numbers to the right. And we want to take advantage of the symmetry of this graph by choosing those points equally spaced. So I'm just going to go one to the left to -1 and one more to the left to -2. And then from 0, I'm going to go one to the right and one more to the right. All right. So then we're just going to plug those values in to get our ordered pairs. So don't forget, your parentheses are very important when you're dealing with roots. I'm plugging -2 in for the x. It has to be in that parenthesis so that when you enter that into your calculator, you should get 4. So this first ordered pair is -2, 4. The second one, we're going to plug in, whoops, looks like I wrote an equal right there, sorry. That's a, oh, it is equal, sorry. Is equal to, if I square -1, that is 1. So this point's -1, 1. And then if we square 0, we get 0. If I square 1, I get 1. And this is where that symmetry is coming in. You see, when I went one step left and one step right, my y values were the same. The same thing should happen here. If I square 2, I get 4. So it did. When I went 2 to the left and when I went 2 to the right, I got the same y value. So that symmetry should show up in all of these parabolas. So let's graph our points. I got -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And all we're going to do is connect these. It continues to grow wider and wider through time. And it's going to do that on both sides. All right, so that's what our parent graph of the parabola looks like. The first kind of thing that we can have that affects the graph of a parabola is having a constant out in front of that squared term. If that number is positive, the parabola is going to open up. If that a is negative, the parabola opens down. And if you take the absolute value of that number, if it is bigger than 1, which basically means it's an integer, that means the graph of the parabola will be narrower than the graph of the parent function. And if the absolute value of a is less than 1, which basically means it's going to be a fraction of some sort, the graph of the parabola will be wider than that parent function. Okay? So for this problem, if you look at it in terms of the general equation, I can see that my a is negative 1/2. That's the number in front of the squared term. So since the a is negative, it means that my parabola is going to open down. And if I take the absolute value, it is less than 1. It's a fraction. So that means that this graph will be wider than the parent graph. All right? So of course, we still have to decide how we're going to choose our values for x. And remember, the vertex is always where my x term is 0. So here I also have just x squared. So the only thing I can square and get 0 is 0. The next one we're going to work will be shifted so that you can see what one looks like when it's not going to be 0 in the middle. Now last time when this happened, we just stepped 1 in each direction and chose -1, -2, 1 and 2. We can do that again here, but of course having that -1/2 in the problem is going to affect how nice my answers are. If the denominator of that fraction in this case is 2, if we choose multiples of 2, we'll get nicer answers. If this was f of x equals -1/3 x squared, we would want to choose multiples of 3. Okay? So I'm going to step 2 to the left and 2 more to the left, and also 2 to the right and 2 more to the right. And that's really just to give myself nicer numbers. Okay? Let's plug them in and see what happens. So if I substitute -4 for the x, now you do not have to show me a bunch of steps here. If you show me this substitution, you are welcome to enter -1/2 times -4 squared in the calculator and just give the answer. When I did that, I got -8. So this first point should be -4, -8. If I substitute -2 for the x, you can enter that again. And for this one, I got -2. So this point should be -2, -2. And if I substitute 0, I should get 0. Here's where you can take advantage of that symmetry. If you enter -1/2 times 2 squared in your calculator, you should still be getting that same y. And we did. It's 2, -2. And then the last one, if we put in 4, we're expecting that y to be 8, and it is negative 8, sorry. So this is 4, negative 8. All right, let's plot our points. So we got negative 4, negative 8, negative 2, negative 2, 0, 0, 2, negative 2, and 4, negative 8. And I'm going to look and see if it looks like it's matching what we said. It does look like it's opening down. And you can see it does look more wide than that original parent graph. So I'm just going to connect my points. And that gives me my parabola. Alright, so the last one of these that we're going to look at kind of combines the stuff that we've learned. So these quadratic functions are actually in what we call vertex form, which looks like f of x equals a times x minus h squared plus k. So the vertex here is going to be hk. So basically what's happening is, remember I said before that the vertex occurs where the x term is 0. Well, this is my x term. It's not just x squared this time. It's x minus h squared. So if I take x minus h and set it equal to 0, I get x equal to h. So that's where we're getting that from. And then if I were to plug that back in, if I put h in the place of that x, then you notice h minus h is 0. So 0 squared is 0, and 0 times a is 0, and that leaves me with nothing but k. So that says y equals k. So that's where it comes from. And then we're going to use this information in the table to answer the questions about the parabola. If the x-coordinate of the vertex h is positive, the graph will shift to the right. If it's negative, it will shift to the left. If the y-coordinate, or k, for the vertex is positive, the graph will shift up. And if it's negative, it will shift down. So let's look at this first one. So remember, to find the vertex, I can take my x term, x minus 3, and set that equal to 0. That gives me x equals to 3. So that means the x-coordinate of my vertex will be 3. And then if I plug that back into my equation, substituting 3 for the x, 3 minus 3 is going to be 0, minus the 4 is negative 4, so that's the y-coordinate of my vertex. And you can go ahead and write h and k above those if you want, because we're going to need them to talk about the shift. Now, another thing we're going to introduce is what's called the axis of symmetry. That's what the AOS is. This is a line that passes through your vertex vertically. So the axis of symmetry is an equation, and it's always x equals the x-coordinate of the vertex. So it's basically a vertical line that's going to cut our parabola in half, okay? Now remember, from my format, the a is what's outside of that squared term, And in this case, there's nothing there, so it's an implied 1, right? So that means for our problem, A is 1. And since it's positive, that means that it's going to open up. The absolute value of 1 is 1. So if A is equal to 1, then it is the same width as the parent function. So remember, if the absolute value of A is bigger than 0, it is narrower. And if it's less than 0, it's wider. So if it's equal to 1, it is the same. Alright, so for the shift, that's where we're going to look back up here. Remember, my H is the x coordinate of the vertex, which is 3. So if the H is positive, the graph is going to shift right. K, in our case, is -4. And if K is negative, the graph is going to shift down. Alright? So the nice thing about this one is the vertex is kind of spelled out. So I know that I'm going to put that one in the middle. So my vertex, when x is 3, the y is -4. My A was 1, so I'm just going to step 1 in each direction again. And then we're just going to plug these in. So in the place of x, I'm going to put 1. And again, you don't have to show me steps for this. Just use your calculator and enter that like it looks. Parenthesis 1 minus 3, parenthesis squared, minus 4. I got 0. So this point should be 1, 0. If we substitute 2, you should get -3. So this point should be 2, -3. If we substitute 4, remember we still got symmetry. So we're expecting the y to be -3, and it is. And for the last one, if I substitute 5, I'm expecting for the y to be 0, and it is. So let's graph our points. We have 1, 0, 2, -3, 3, -4, 4, -3, and 5, 0. And if we look back at what we wrote, we said that it was going to open up. It does look like it's going to open up. It does look the same width as the parent graph. It is shifted to the right, and it is shifted down. So that's the graph of my parabola.